Three. Yeah. Hello everyone. Welcome to the Tech Rocks Advanced ECE Masterclass session 9. And now, in this session, we're gonna discuss about RTL Logic Family and applications and the EDA tools and essentials. Okay. We have some EDA tools like Flux AI, okay, which will be designing the PCBs using AI in it. Now we have the KiCad, EasyEDA Pro, and we can use Microwind DSCH for VLSI gate level design and chip level design. So we will look into that and we stick to the computers and your devices. And let's start. Management team, just let me know if the screen is correctly sharing or not.
Think so.
Yeah, is it visible?
Right, yes.
Yeah. And also do share the live link to everyone in the Tech Rocks group, okay? Like the new groups of outreach and management. Now, let's discuss about the RTL logic design. Okay. Now, what we should know is what is RTL. Okay. The register transfer level is a design abstraction used in writing synthesizable software. Okay. It is like abstraction which is used in synthesizing the hardware using the HDLs. Okay. Like verilog or VHDLs to define digital circuits. Okay. This is a kind of a logic statement which is written in VHDL. Now, its core operations will be on data flow and operations like, okay, it says, okay, this RTL says that how data transfers and transforms between memory elements which are registers. And we have the shorthand abstraction, okay, which abstracts low level gate structures. Now, facilitates rapidly, yeah. Am I visible on the live set or more people are coming? Yeah, thank you team for responding as soon as possible. Yeah. Now, what we have is we can abstract low level gate structures and facilitating rapid system architecture scaling. Okay, like it is like a kind of a logic statement. Okay, we have it like that. Okay, in the VHDL and Verilog, we are using RTL to describe the data flow and how the operation must be done. Okay, now the main target hardware, which is like the high frequency FPGAs and ASIC design pipelines. As we already know, ASIC and FPGA are highly customizable. ಬರ್ರೆ ಗೊಂತ ಎಷ್ಟು ನಾವು ಹೊರತಾರೆ? Yeah, now you can see a simple data flow architecture which we have a register A and a combinational logic will be carrying all the data. Okay, now the combinational logic data is transferred to register B. This is how the small system runs. Now let us see why we should learn the RTL design. Okay, the requirement of the RTL designer in a chip design market is very high. Okay, like the global semiconductors like Qualcomm, NXP Semiconductor, and we have NVIDIA too. Okay, we have ASML, we have Intel chip manufacturers and TSMC manufacturers. Okay, so they saw the rise of the demand of RTL design engineers. Okay, These are like an extreme level opportunity for any EC student or a triple A student, but the skill is very low. So you need to learn the RTL design in your curriculum itself. Now, first to learn the RTL design, you need to learn all the concepts of the HDL and VHDL, and then you need to be good at the circuit designing, and then you can start learning the RTL parallelly. I have already said the target devices are FPGAs and ASIC. Okay. Now, the RTL forms the primary skill set required to design highly sophisticated system chips or programmable logic structures, which are FPGAs. Okay, it is like the first and main most important thing to learn to become an ASIC engineer or any FPGA engineer. Now, in hardware verification, you can unlock high value career paths in silicon testing. Mainly, into the testing side, the RTL engineer must be there. Okay, like they will be hard coding every chip. They will be testing in all the norms, and they will decide that it is a chip. Okay, this is let's say somebody is processing a test bench on the chip inside this phone. Okay, now what he will do is he will write all the codes which are required, and he will note all the desired outputs. Okay, he will check that the outputs are matching or not. Okay, if not, he will mark all the errors and he will share it to the verification team, and then they will remanufacture the product. Okay, this is how the test benches will be done. Now, to learn the RTL basics, you need to learn, as already we have been discussing about this, the number systems and levels, Boolean mathematics like the gates, okay, algebra, and Karnaugh maps for circuit optimization. Like optimization in the sense reducing the complexity of it, okay, and increasing the efficiency. You just know, and just note it down that the optimization refers to the reduction of the power, reduction of the power loss, and the reduction of size. Okay, you people already know about the fundamental logic gates like AND gate, OR gate, XOR gate, etc. etc. You just need to remember all these logics. Okay, now the CLBs in an FPGA or an ASIC consist of binary adders, mux. Okay, now we have digital decoders and encoders. Whatever the combination circuits will be there, we can be implementing combination logic blocks. Okay, like for example, in an ALU, you will have a binary adder. Okay, or else an adder, subtractor, whatever it is. Okay, these are these are some components of the combination logic block. For example, let's take మనకి ఇప్పుడు వెహికల్ లో కాంబినేషన్ లాజిక్ బ్లాక్ ఎలా చూసుకోవచ్చు. లెట్స్ ఇమాజిన్ ఆ బైక్. ఓకే, స్టాండ్ తీయండి, ఇప్పుడు బైక్ ఆన్. ఓకే, ఇస్ ఇట్ నాట్ గేట్? ఓకే, ఇట్ ఈస్ నాట్ గేట్. ఫర్ ఎగ్జాంపుల్ ద దాన్ని ఏమంటారు, ద స్టాండ్ ఈస్ ఆఫ్. ఓకే, ద స్టాండ్ ఈస్ ఆఫ్, bike will be getting on. Okay, we can turn on the bike, or else if the stand is on, we can't turn on the bike. Similarly, here the NOT gates and gates are used in such way, and also we have the AND, like in case like the both inputs are on, it will show that the carry will be generated and the carry will be processed to another logic blocks. Like that, the combination logic blocks are interconnected in a FPGA or any kind of system. Now, obviously, we know the sequential logic blocks, which are the flip-flops, registers, shift registers, etc., etc. And also, you can consider the memory units too. Okay, these logic blocks need clock. The clock signal of gigahertz, megahertz, terahertz, like that. Okay, actually, we have only gigahertz, not terahertz. Terahertz is way more than our imagination. Okay, now let's see some of the simple terms of the sequential logic blocks which are commonly used. Now we have the clock signal. Okay, it governs the synchronous execution across system registers. Okay, like they must run on the same path and on the same timeline. If not, the data will be lost. Simply yes or no. Just it's yes. Now we have the memory units, the D flip flops. Okay, and the memory state machines. Now we have the counters and shifters used for sequencing and parallel data serialization. Okay, you just note it down somewhere or take a screenshot of. You might require like to know the basics of all. Now let's go to the introduction of Verilog HDL. Okay, it is a you just think of it. Verilog is a IEEE standard design description language. Like we have the Python for automation, C++ for OS development, and Java and JavaScript for software and web development, right? So like that, for the hardware design and description, we have Verilog. Okay, it is an IEEE standard design, and it is used to model, simulate, and compile the digital hardware topologies. Okay, like we have the gates and the logic blocks, whatever it is. These are designed and simulated using Verilog. ఓకే. ఇట్ ఈస్ నాట్ ఏ స్టాండర్డ్ సి కోడ్ లైక్ మీరు ఇఫ్ ఎల్స్ స్టేట్మెంట్‌లో రాసేస్తే అయిపోవడానికి. ఇట్ ఎగ్జిక్యూట్స్ కాంకరెంట్‌లీ ఇన్ త్రూ ఫిజికల్ హార్డ్‌వేర్, నాట్ సీక్వెన్షియల్. ఓకే. ఇట్ వర్క్స్ ఆన్ ది ఫిజికల్ హార్డ్‌వేర్, నాట్ ఆన్ ది సాఫ్ట్‌వేర్. ఓకే. నౌ it also supports the synthesizability. The RTL compiles down directly into transistors on silicon wafer or logic blocks on FPGA. ఓకే. RTL డైరెక్ట్‌గా మనకున్న ట్రాన్సిస్టర్స్ మీదనే ఎఫెక్ట్ చూపిస్తది. లైక్ ఇప్పుడు మనకేంటంటే సి ప్లస్ ప్లస్ గాని, ఇది గాని సిపియూ మీద లోడ్ చేసేసుకొని సో దే విల్ ఎగ్జిక్యూట్ దేర్ ప్రోగ్రామ్స్, రైట్? సో హియర్ ఇన్ దిస్ ఆర్టీఎల్ కేస్ ఇట్స్ నాట్ గోన్ బి హ్యాపెన్. సో ఇక్కడ ఏమవుతుందంటే కంప్లీట్‌గా హార్డ్‌వేర్ లెవెల్‌లో మనం ప్రోగ్రామింగ్ లాంగ్వేజ్ రాస్తున్నాం. సో దట్ ఈస్ కాల్డ్ ది ఆర్టీఎల్. నౌ లెట్స్ సీ Verilog module structure, okay, which is a building block of the syntax. Just let's see. Management team just check whether the live is clear or not. Like, am I audible on live? And am I visible on the live? Like my
Yes, sir.
screen
Yes.
and
All clear. All
yeah,
clear.
yeah.
All.
Thank you, thank you. Now, the fundamental structure unit in Verilog is the module. Okay, so you have the standard input output or import in Python, right? So like that, we will import a thing like let's take an example of this program, like whatever displaying it here, okay, from a Python language. Now what we will do is import in Python. We will write as import numpy as pandas, and we have the inputs. Okay, int a is equal to int b is equal to output c is equal to whatever it is. We are taking them and we are defining it. So in the same way, in the Verilog, okay, we are importing the AND gate here. Okay, it is written as AND underscore gate bracket. Now we are defining the inputs and output. Okay, input wire A, input wire B, like int A, int B, and output in C. So now you are defining the thing. Okay, you are defining the thing here. Assign y is equal to a and b, and you are ending the module there. Now you can see, is it written as y is equal to a plus b or a minus b like that? Is it or not? Just give me a thumbs up. Anyone? అలానే ఉంది కదా ప్రోగ్రామ్ అంతా. Now here we have the ports, which declares bidirectional inputs and output interfaces. Now the continuous assigns. Okay, these build raw combinational path linkages. Okay, now we have core RTL coding styles. We have data flow modeling, behavior modeling, and structural modeling. In this data flow modeling, okay, we will represent the concurrent logic signal transfer using continuous assign operation. Okay, it is basically used for simple combination flow sheets. Like we have ఒక basic level or simple level programs and నేర్చుకోవడానికి we are using the data flow model. Now we're coming up to the behavior model. These are models complex logic behaviors using procedural blocks like always, if else, like the if else statements in the traditional programming languages of C and Python. So you need to understand the C and Python, then you can easily understand the VHDL and verilog. Okay, like you will learn all these. Okay, now these are these require the high level abstractions for state control because ఇది మనకేంటంటే కాంప్లెక్స్ లాజిక్ బ్లాక్స్ ని చేసుకోవాలంటే instead of writing the whole code in 10 to 20 lines, we are using the if else statement, right? So in the same way, here we are using the procedural blocks. Okay, it is like a procedure కదా. For example, నాకు ఈ మనిషి దగ్గర ఒక ఇద్దరు ముగ్గురిని ఒక ఇద్దరు ఏజెంట్లను పట్టుకుందాం అనుకున్నాం. సో ఒక ఏజెంట్ దగ్గర లేకపోతే ఇంకో ఏజెంట్ దగ్గరికి వెళ్ళాలి. ఒకవేళ ఒక ఏజెంట్ దగ్గర ఉంటే ఇంకో ఏజెంట్ దగ్గరికి వెళ్ళకూడదు. సో దిస్ ఈస్ హౌ ద ప్రొసీజర్ వర్క్స్. ఓకే, ఇన్ ద సేమ్ వే ఇఫ్ అనే స్టేట్మెంట్ ని వాడుతున్నాం, ఆల్వేస్ అనే స్టేట్మెంట్ ని వాడుతున్నాం, ఇఫ్ ఎల్స్ అనే స్టేట్మెంట్స్ ని వాడుతున్నాం. సో దట్ ఈస్ నౌ వీ హ్యావ్ ది స్ట్రక్చరల్ మోడలింగ్. It is completely based on the verbs low level logics. Okay. Now it also provides the submodules and the primitives together and reflects a literal logic design schematic architecture. Okay, it only reflects the logic design and schematic architecture. Now let's see a basic combinational RTL coding. 2 to 1 multiplexer RTL code. Okay, using continuous assignments with conditional operators generate efficient combinational multiplexer blocks. Now we have here you can see inputs in one and in zero and in one. Okay, via selection line. Okay, selection is present here. Now we are assigning here. Okay, assign out is equal to cell, and you will be keeping that in the bracket. Now we will assign a question mark, and in one is in zero. So that is how it is assigned. Okay, rest of the all the upper level code like I have showed here, right? So the inputs will be already defined previously, and only the assign will be shown here. Okay, you don't worry about, or else you don't think that ఇదే మొత్తం సింగిల్ లైన్ ప్రోగ్రామ్ అని కాదు. ఓకే, ఇది కంప్లీట్ గా సింగిల్ లైన్ ప్రోగ్రామ్ అని కాదు. జస్ట్ ఏంటంటే ఆల్రెడీ మనం డిఫైన్ చేసుకున్నాం కదా. దిస్ పీపీటీ షోయింగ్ దట్ how to assign. Okay, that's it. Now we have the sequential RTL coding. Now we capture, okay, these are like clocked always blocks, okay. Now we capture synchronous flip-flops using behavior always structure triggered on a clock active transition edge. Now we have the pose edge clock or trigger. Okay, evaluates exactly on the rising edge transition. మనకి ఇప్పుడు ఏంటంటే ప్రతిసారి ట్రాన్సిషన్ వస్తూ ఉంటుంది కదా అవుట్పుట్ లో. సో ఇన్ దాట్ కేస్ ఇట్ విల్ బి వర్కింగ్. Now you can see always at the rate of posage clock or posage rest. Okay, begin if rest is equal to q greater than or latest greater than or equal to 1 into b now. Now he is writing an else statement and he will be ending there. Now let's see about blocking and non-blocking. Okay, the blocking statements evaluate and update immediately in sequential line order. Okay, it is mainly used in combinational logic blocks. Now in the non-blocking statement, the evaluation will be the input evaluation will be done immediately, but update outputs at step boundaries. Okay, the evaluation of the inputs will be in the light speed. Okay, but all the outputs will be updated in the just nano speed. Okay, it is mainly suitable for sequential registers. Now we have the FSMs. Okay, you people already know about the Moore state law machine and Mealy state machine. Okay, you can just check it out afterwards. Now we have the RTL design flow. First, you need to write down the specification. Obviously, for any project or any kind of thing, you need to know the specification. Then you need to do the RTL coding now. And in the third step, you need to do the simulation. Okay. Then you need to do the synthesis and implementation. Now, the simulation and verification will be done on pre-silicon. Okay, not the on the silicon. It is done before the silicon wafer. Okay, verification compromises over 70% of modern chip design efforts. Okay, writing highly robust test benches guarantees logic correctness. Okay, before physical development. Just you can see the main difference between the FPGA and an ASIC. Okay, the unit cost is higher. Okay, and in the ASIC, the extremely cost is very low in high production volume because these are generated for the application specific. Okay, సో వీటిని ఏంటంటే ఒక పని కోసమే తయారు చేస్తారు కాబట్టి the components will be less and in high volume production the cost will be less. But where it is in place of FPGA, the thing is like మీకు కంప్లీట్ యూనిట్ వస్తుంది కదా, సో యూ నీడ్ టు పే ఫర్ all the units. Okay? Now the reconfigurability of FPGA is it is fully reconfigurable, and in case of ASIC, okay, in case of ASIC, it is fixed and unchangeable once manufactured, like our ICs. ఓకే, ఒకసారి నువ్వు ఐసీ 555 ని మ్యానుఫ్యాక్చర్ చేసావంటే ఇంటర్నల్ లాజిక్ ని మార్చలేదు. సో ఇన్ ద సేమ్ వే లైక్ దిస్. నౌ వీ హ్యావ్ ది maximum performance. Okay, the metric is about the maximum performance. Okay, the maximum performance will be achieved at moderate frequencies and constrained logic power and in ASICs. Okay, the maximum performance will be attained and low physical power footprints. So enduku anante the whole thing is generated for a specific work. So obviously it will show the maximum performance. Now it's see about the time to market. Okay, it is ultra fast, but where it comes to the ASIC, it needs long term development cycle because it is an ASIC, right? So we need to test in all the terms. FPGA ఏంటంటే already pre-designed ఉంటే so they can send it to the fabrication unit. Okay, like that. Now the industry standard tools which are used for the RTL design are and for the FPGA mainly we have AMD Xilinx Vivado and Siemens Model Sim and the Cadence and Synopsys. Okay, you can simply explore those things and we will share the resources too. Now, some of the projects which are needed in RTL mini projects are 4-bit ALU design, a traffic controller, or a UART controller. Okay, you can perform this using any DSCH or something. You can simply contact me if you want to do. Okay. Now, with this, I am concluding the complete VLSI design topics. Okay, if there is any doubt, you can simply contact me personally on my number or on my mail, which is management@techrocks.in. Okay, or else you can use info.e@techrocks.in. You just write it down and you can simply mail me whatever your doubts. Okay, now the most interesting part of every electronics aspirant is going to start, which is the EDA tools. Now we will see what are the tools available for the PCB design, okay, the simulation and whatever it is. Okay, I will let you know, okay, how to design your PCB and how to make a schematic. Like in case of you're making your major project, minor project, or real time project. Okay, in that case, you might be wondering like how to design a schematic. Now I will show a easiest way to draw all the schematics very easily. Are you people ready? Just give me a thumbs up, whoever in the live or in the meeting. Yeah. Also, you people don't think that, okay, whoever in the meeting or in the live, don't think that you people don't know anything regarding this. Like, మీరు ఏమనుకుంటుండొచ్చు అంటే ఆమె ఫస్ట్ ఇయర్ అని ఆమె సెకండ్ ఇయర్ అని సో ఐ విల్ టీచ్ ద బేసిక్ కాన్సెప్ట్స్ విచ్ విల్ బి డైరెక్ట్లీ హిట్టింగ్ యువర్ మైండ్ ఓకే నౌ ఐ నీడ్ యూ టు జస్ట్ నోట్ డౌన్ or else go through a Google Docs or anything. Just type it there itself, and you need to practice. Okay. And also, if there is any doubt or something, you can simply contact me any day, anytime, anywhere. Are you people ready to do this, like in practical way or not? Okay. Just stay tuned. Okay. And hang tight to your laptop. Just we will start the breath. Now we will do one thing. First, we will go with KiCad. Okay, the KiCad is a tool which is an industry grade. First of all, we can say it as industry grade. Use it for the PCB design, simulation, whatever you need, it can do. Okay, now this was the previous circuit I have done. Okay, just let me know. Do you people know about the Arduino or any ESP32 or any Raspberry Pi or something? Just give me a thumbs up if you know the Arduino, the basic one, Arduino. Or else, if you can't recognize, just let me show what is Arduino. So this is the thing which I am talking about. Okay, I think most of the people know about this, right? Fine. Now, I have a small project. Okay, for that we will draw the schematic and we will design the PCB. Okay, the very basic way, not like an industry grade PCB or something. Just let's say basic one. Okay, on both EasyEDA, KiCad, and Flux. Okay, with this session, you will get to know what are the tools available for the PC students. Mainly, also you can explore the certification from RTM, which is a industry grade one. Okay, it is like a diamond standard of the electronic design, like for the PCB or whatever. Because it also provides the cloud integration. You can work on cloud with the team, okay, with the team of collected people, okay, work online on a single project, okay. So you can go through the RTM certification too. In the upcoming sessions and bootcamps, we will discuss about those things. Before that, let us discuss about this. Are you people ready? Just give me a thumbs up on both live and meeting. Yeah. Now let's go on to the KiCad. Okay. Just write it down. The KICAD if you don't have any laptop or if you are using your mobile. Just to make the schematic. Okay. మీకు ఇక్కడ ఏమేమి కనిపిస్తున్నాయి ఇవన్నీ ఏంటో నేను క్లియర్గా చెప్తా. జస్ట్ let's click on the control plus. Now you all know the file section where you will save or current sheet as, like you will change the name or else you need to revert or something, or you need to import, okay, and you need to export something, you can do it, and you can do the schematic setup and the page settings, and you can also print from here itself. Okay, now here we have the some of the elements and grids and text like kind of. Okay, now we have the shapes also. Just let's take the shape. Okay, now we will do one thing. Just in case of any missteps, you can click ESC. Okay, if you are like just getting like this, or okay, by mistake I touch this, then you can click ESC, or you can select on this and delete. Okay, now in case of placing a microcontroller here, you need to do is just go to click on this, and just we will select the basic audio. Okay, I just forgot to say that మనకి ఇప్పుడు ఇంజనీరింగ్ గ్రాఫిక్స్ లో షీట్స్ ఇస్తారు కదా, సో దిస్ ఈజ్ యువర్ షీట్ where you will be designing the circuit. In case మీరు ఒకవేళ దీన్ని మూవ్ చేయాలనుకుంటే, if this is in this mode, okay, you can't move it. Okay, if you touch it, another pop-up will come. In that case, you can use this one. Okay, this is the icon which you need to tap to move any microcontroller. You just click on it, it can freely move from wherever you want. Okay, now we will just erase this thing. Okay, size కొంచెం చిన్నగా అయిపోయింది. So I just took. సో మనం ఈ బాక్స్ లోని చేసేసుకోవచ్చు. For example, we got a Arduino now. మనకి ఇప్పుడు ఏం కావాలి? ఒక నార్మల్ సెన్సార్ ని తీసుకుందాం, which is DHT11 అనుకుందాం. Okay. Now we will take the I2C module of this is the 1306 display. What is the display available? Not this, not this. 16x2. Yeah, we got. సో మనకి ఇక్కడ ఏంటంటే ఒక I2C మాడ్యూల్ అవసరం పడుతుంది. Okay, we will just eliminate this one. Okay, మళ్ళీ నేను అది తప్పు చేస్తున్నాను. So I need to click this one. Now we will eliminate this using delete or something. Okay, also మీరు ఇక్కడ ఏం చేయొచ్చు అంటే, if you click on this, okay, you can configure it however you want. Okay, ఆ configuration అంతా మనం తర్వాత తెలుసుకుందాం, but at least we need to know how to draw our own circuit. So just మీరు ఒక చిన్న బేసిక్ చెప్తా. మీరు జూమింగ్ అండ్ మూవింగ్ అనేది చూసారు కదా. సో if I move upward, what will happen? Let's see. Okay, I'm now moving my fingers top of the scroll pad. Like మనకి ఉంది కదా, మౌస్ ప్యాడ్ ఉంటుంది కదా. సో దాన్ని ఇలా మూవ్ చేస్తే, సో దిస్ ఈస్ వాట్ హ్యాపెన్. If I move it down, okay, it's zooming. If in case I'm moving up, it is zooming out. Now మనం ఏం చేస్తాం, ఇట్లా నార్మల్ గా మనకి ఏంటంటే జూమింగ్ లో మనకి ఇది లైక్ we will be pinching it or pinching it out. So what will happen? I will show. If I pinch out, and like if I drag it out, what is happening is it is moving to the left. If I pinch it inside inwards, okay, so it is moving to the right. So in case నేను ఇక్కడ జూమ్ చేసుకోవాలనుకుంటున్నా, so I will do one thing is I will place the mouse pointer here. Okay, so I will simply move my fingers down and it will auto route itself to the center. Now it comes to the main position and the desired place will be zoomed in. Okay, now మనకి ఏంటంటే we have the power signal. మనం అక్కడ ట్యాప్ చేయగానే ఇక్కడికి ఇగో ఈ పాయింట్ మారిపోయింది, which is draw wire. So in case you need to turn this, okay, in case you need to turn this, మీరు ఇలా టర్న్ చేస్తే సరిపోద్ది, or else you can simply tap it. It won't move from there itself. Okay, సో ఇప్పుడు ట్యాప్ చేయకముందు ఏమైంది, అది డైనామిక్ గా మూవ్ అవుతుంది. బట్ ఇఫ్ యూ ట్యాప్ ఇట్ హియర్, ఓకే, ఇట్ విల్ బి స్టేయింగ్ దేర్ ఇట్సెల్ఫ్. ఓకే, ఇన్స్టెడ్ ఆఫ్ దిస్ లైక్ షార్ప్ కార్నర్ పాయింట్స్ తీసుకోకుండా నేను ఏం చేస్తున్నానంటే ఇలా తీసుకొని, ఓకే, సో ఐ హావ్ కనెక్టెడ్ టు ది VDD to 5. Now we have the ground, which is a common one. Okay, you can simply move it inwards, okay, so that to reduce the size of the circuit. Now we will do one thing. Just click on Control Z. Now let's click on Control Z once again, and now the ESC. Now what we're doing is shifting the side of this to this side. Now we will eliminate this one. We will eliminate this connection too. Okay. Here it got shorted, so we should remove the connection there. Okay, we will do one thing. Just we will move this thing inwards. Okay, now it is clear. We will simply connect this terminals. Now it is connected to the ground, and then all the data pins are here itself. Now what we will do is we will simply connect it to any point. Okay, which is D7. For example, మనం ప్రోగ్రామ్ చేసేటప్పుడు క్లియర్ గా మనం ప్రోగ్రామ్ చేస్తాం. Okay, it's pretty easy. So now we need to connect this one. Okay, this is an I2C module which is powered with a 16x2 display. Now as it is, నేను మళ్ళీ దీన్ని ఏం చేస్తున్నానంటే తీసుకెళ్ళి ఇక్కడ 5 ఇంకొకటి లేదు కాబట్టి తప్పదు కాబట్టి ఇక్కడ మళ్ళీ తీసుకొచ్చి దీనికే అంటగడతాను. Now what I am doing is the VSS to the ground. Okay, VSS or something you can simply connect it to the ground. Sometimes VDD can be the ground. Just check it out whether you are connecting to the right port or not. Like మీరు క్లియర్ గా చేస్తే నో ప్రాబ్లం. ఓకే, యూ క్యాన్ సింప్లీ మెన్షన్ దే. సో మనం ఏం చేద్దాం అంటే ఇప్పుడు దీన్ని గ్రౌండ్ లాగా చేసేస్తున్నాం rather than keeping it as VSS. No problem, like it's a power signal out మనం ఏం చేస్తున్నాం నార్మల్ గా VSS ని తీసుకెళ్ళి గ్రౌండ్ కనెక్ట్ చేసేస్తున్నాం, no problem. Now the port we need to connect is the SCL. So you can see the serial clock here. Now you will connect the SDA here, serial data. Now we have completed the making of the circuit of a simple temperature display unit which is powered by a Arduino Leonardo and a 16x3 display with I2C module and a DHT11 sensor. Now what we will do is uh, we can simply print it out, or else we can simply export it to the main sheet and మీరు documentation చేస్తారు కదా, so you can simply place it on it. Now what I will do is సేమ్ ఇదే మాడ్యూల్స్ నేను ఇక్కడ దీంట్లో తీసుకెళ్తున్నాను. So this is a PCB editor. Okay, now in this we will get, okay, now we need to get a Arduino. మనం Arduino Leonardo Arduino Uno వాడినా it's okay, no problem. But make sure that you are placing the Arduino in the right way. Okay. మనం ఇలా అయినా పెట్టుకోవచ్చు or else just yeah. మళ్ళీ ఇక్కడ సేమ్. సో ఎప్పుడైనా కానీ మీరు బోర్డుకి కార్నర్ లో మనకి పోర్ట్స్ అన్ని రావాలి. సో ఇన్ ఆర్డర్ టు పవర్ ఇట్ ఆర్ సంథింగ్ యూ క్యాన్ యూజ్ ఇట్. ఆర్ ఎల్స్ మీకు ఇంకా బెటర్ గా చెప్పాలంటే మీరు ఇలా మధ్యలో ప్లేస్ చేసేసుకుంటే బోత్ సైడ్స్ మనకి అన్ని పెరిఫెరల్స్ ని మనం కనెక్ట్ చేసేసుకోవచ్చు. నో వి నీడ్ డిహెచ్సి. నెక్స్ట్ మనకి ఏం కావాలి, ఎస్ఎస్డి అన్నమాట. సో ఓలెడ్ డిస్ప్లే అనుకున్నాం. ఇలా కాకుండా I2C తీసుకుందాం. మనకేంటంటే ఇప్పుడు దీన్ని ఇలా పెట్టేసుకుందాం. బికాస్ వీ క్యాన్ పవర్ వీఆర్ మేకింగ్ అ డివైస్ కదా. సో మనం ఏంటంటే ఈ డిస్ప్లే అనేది ఐఎమ్ మేకింగ్ అ ప్రోడక్ట్ హియర్. జస్ట్ ఇమాజిన్ ఇక్కడ నేను ఏం చేస్తున్నానంటే ఇప్పుడు ఇది నా డిస్ప్లే అనుకోండి. సో ఐఎమ్ ప్లేసింగ్ ద డిస్ప్లే అప్వర్డ్స్ అండ్ ది ఆర్డినో అండ్ ది ఎంసియూ టు ద డౌన్వర్డ్స్ బికాస్ వీ నీడ్ టు పవర్ ఇట్. సో పవర్ చేస్తే సో వీఆర్ పవరింగ్ ఫ్రమ్ ది డౌన్ సైడ్ డౌన్వర్డ్స్. ఓకే. సో ఏంటంటే డిస్ప్లే మనకి ఈ సైడ్ కనిపిస్తుంది. ఓకే, వీఆర్ నాట్ మెస్సింగ్ అవుట్ విత్ ద వైర్స్. సో దట్స్ వై ఐఎమ్ డిజైనింగ్ లైక్. Now, what we will do is we have to know what are the ports are there. So let's assume like మళ్ళీ మనం అంతా కన్ఫ్యూజ్ అవ్వకుండా ఉండాలంటే let's assume this is our power signal and now we gonna wire it down. Okay, now we have the power signal here. Just let's assume that here it is a 5V. Now let us power it with, okay. Now this is a ground signal, let us assume, and now we need the data pin. Okay, we are connecting it in such a way that the power transfer will be very efficient. Okay, let's connect it to the DH. Okay, underneath there will be no connections, right? So it is an empty space, so we are utilizing that one. Okay, now let us take it is the SCA. So the SCA will be connected to the, let's take the blue one. Okay, Let us utilize another layer for this. Okay. Just click it so that it can move here and there. Now we need to connect the power thing. Okay. Now I need to connect the ground. Here we can also connect the ground here. Now we have connected the I2C display. Now what we need to do is you can simply move it here. Okay. Now you can visualize the layers of the PCB. Now what you can do is you can simply visualize in 3D like how the PCB looks. Okay. So this is how I made it. Okay, you can simply see like how it's done. Okay. So you can see the underneath the connections and whatever we have done here. See, this is how it's done in the PCB. Okay, this is how a basic PCB is done. Now this is how it's done. You can simply save it. Okay. Now you can exit from the KiCad. Okay. This is how you can use KiCad for your basic projects. Okay. There are a lot more things to learn in KiCad. So you can take time or you can simply contact us. We will make you like we will teach you people. Now, is it clear on the YouTube people or the meet ones? Just let me know if the thing is clear. Like you people understood something or not. Just give a thumbs up if you understood what I'm saying. Now, let us move on to the Flux. Okay, which is very easy to do software. Flux AI is a credit-based software, so you need to change your account if your credits got expired. Okay, we will just take it down here. Okay, maintain few more accounts if you need to do more projects. Okay, if you want to explore more about this, you can have n number of accounts. Now let's log in with my another account. We will go on to the other accounts so that we can work on them. Mm, just we will skip this part. We will skip this part too. Now we will the Flux here. Forward from the existing account as its free tier is expired. Now what we will do is we will use our new account. As we will see as Roxy 2026. Um, just you can fill whatever it is. Okay. Let's skip this. And we can go to the previous account itself so that I yeah. Now you can import a new project. I think we need to delete all this so that I can make a new one. Okay, like regarding the Flux, we will once check it out and we will share the documentation of this because it's persisting some issues. Okay, just like it is like if you give the prompt, it will give the code, and you need like it will give the schematics and PCB. Okay, so this is the PCB design CAD where you will be using it for the PCB design. Okay, so you need not to worry much about this thing. Okay, it's very easy to use, but to take you need to pay something to do the project. So for this, you can simply explore on your words. Okay, like you can explore like giving a simple prompt. Okay, with that you can generate the thing. Okay, fine. Now let's move on to the EasyEDA Pro as I already said. Okay, now we shall terminate all the sessions of the yeah. Okay, because these softwares are like kind of very large, you need to close all your tabs to run them. Okay, and also whoever you might be having some friends, right? Okay, you will get the YouTube live link. If you have any friends who are ready to learn, okay. Now can you see the screen? All of you just respond. Just say yes or give a thumbs up. Yeah. And management team, kindly check the live.
Yes, sir.
Yeah, is it visible? Just let me
Yes,
know.
sir. Yes, sir. Visible.
Yeah, thank you for responding. Now, what we will do is just you can see here in the home page, you can see whatever you have done before. Okay, whatever the projects you have done before. Okay, and all the things like the footer will be appeared here. You can see all the things. Okay, just like a simple dashboard for you people. Okay, you can simply ship it from here. Also, you can buy the PCBs using the JLC PCB. Okay, like we have the JLC PCB here. Okay, now you can see the quick start bar where you can start with a new project or you can simply open a new project. Okay, open the existing project or a new library or new component or you can add new footprints. Okay, footprints are nothing but the base of the item which you need to place. And if there is any 3D model, you can import from here. Okay, new reusable component you can simply do that. Import Pro version, import standard version, and also you can import Altium. Okay, you can import from the Altium too. You can also import the KiCad files here. Now, some other PCB design platforms will be there, right? So you can import those files also from import other option. You can also check the settings option. You can see whatever the settings that are there. Just you can customize on your own. Okay. Here are something called the tutorials, videos, and how to do everything. Okay. This is like kind of a library here. You can use it. Now, let us go on to the new project. Let's say it as S9 demo session. Okay, you can add a description so that if you have shared this file to any person, okay, he can read the description there. Okay, you need to make sure that you are very clear about the description. Okay, and you can see this like where it got saved. Okay, the project part. Now, similarly, you can. Okay, all things are same. Okay, everything is same between those. Okay, you need to click on this. Just say we have ESP32. Okay, the main difference between the KiCad and this EasyEDA Pro is it is equipped with Raspberry Pi. Any microcontroller you want, it is present here. Okay, you can see like how many of the products are here for the simulation. Okay, you can see like what is the flexibility provided by them. Let's say I have given that ESP32 dev kit. Okay, మనం అంత పెద్దగా చేయాల్సిన అవసరం లేదు కాబట్టి సో we will do one thing. We can do it. Audio. Okay, don't forget to click on the enter. Okay, so it needs to reiterate and it will be processing everything. We will import the thing. For example, I think we got the ESP right. Now you will see. Okay, if we got it here. Okay, we got the image here. You can see that here you have a button called place. Okay, just let's perform a URT programming. Okay, just మీరు ఇట్లా ట్యాప్ చేస్తూ వెళ్తే మల్టిపుల్ నెంబర్ ఆఫ్ డివైసెస్ వస్తుంటాయి సో యూ క్లిక్ ఆన్ ది ESC or escape so that the thing is will be erased. Now మీకు ఇక్కడ బోర్డ్ వన్ ఉంది అని వస్తుంది కదా సో యూ క్యాన్ సింప్లీ ఎడిట్ ఎవ్రీథింగ్ హియర్. ఓకే నా ఇన్ ఆర్డర్ టు వైర్ ఇట్ మీరు ఏం చేస్తున్నారంటే లెట్స్ టేక్ both of them into the common ground first. Let's check whether the connection is good or not. Okay, now the connection is done. So whatever we're doing is just click on the ESC, the connection will be gone. Now let's see, we have the UTXD and RXD, right? So I will connect the RXD to Yeah. Okay, now I will take this RHD from here and I will move it to here and I will connect it to this TXD. Okay. And ఏంటంటే we have TX, RX, TX, RX. We are cross combining both of them. అంటే ఒకదాని రిసీవర్ ఇంకో దానికి ట్రాన్స్మిటర్ అవుతుంది ఇంకొక దాని ట్రాన్స్మిటర్ దీనికి రిసీవర్ అవుతుంది. You just need to be clear about this thing. So everything is will be well working. సో ఇప్పుడు ఏంటంటే నేను ఇక్కడ ఒక చిన్న యూఆర్టీ దానికి ఒక చిన్న కస్టమ్ పీసీబీ డిజైన్ చేస్తున్నాను అనుకున్నాను. సో థింగ్ హ్యాపెన్స్ హియర్ ఇస్ యూ నీడ్ టు గో ఆన్ ది స్కీమాటిక్ అయిపోయింది. ఓకే, నౌ వి షల్ మూవ్ టు ద పీసీబీ. అంటే మరి అంత ఎక్కువ టాపిక్ పెడితే మీకు కూడా బోర్ వచ్చేస్తుంది. సో మీకు ఇక్కడ ఏంటంటే EasyEDA gives you more flexibility on chips. ఓకే, మీకు యాజ్ ఇట్ ఈస్ అక్కడ ఎలా ఉందో ఇక్కడ కూడా అలా ఉంటుంది. సింపుల్. ఇక్కడ సిమ్యులేషన్ ఎలా చేస్తారంటే ఇలా సింపుల్. సో ఇక్కడ మనకి ఏంటంటే పీసీబీకి ఉన్న సైజ్ ని చెప్తుంది. సో యూ నీడ్ టు డూ దిస్. సో మీకు ఇక్కడ కావాల్సిన టైప్ ని మీరు చేసేసుకోవచ్చు. అండ్ యూ నీడ్ టు సెలెక్ట్ లేయర్స్ అండ్ లాక్ అండ్ ది స్టార్ట్ ఎక్స్ అండ్ స్టార్ట్ వై. ఓకే, సో మీరంటే ఏంటంటే ఒక పీసీబీని ఇక్కడ మనం డిఫైన్ చేసుకుంటున్నాం అనమాట. సో నథింగ్ మచ్. ఓకే, దిస్ ఇస్ ద గ్రిడ్ చేంజర్. Where are the components? I can see them. Yeah. Now I have selected the project here. Mm, like this. So this is how I will let just say and then నేను ఒకసారి చూసి clear గా చెప్తాను. Some a bit of confusion ఇస్తుంది okay. So let's see more about the EasyEDA Pro tomorrow itself because we gonna start the PCB design tomorrow and I will guide you through the certifications. Okay. So what is there, what you have to learn and repeat. Okay. Now and also the practical session of EasyEDA Pro will be done tomorrow. And also we are concluding the session from here itself. And by tomorrow, the session 10, the complete cohort will be coming to the end because of the ineffectiveness of more people. So we are segregating everything into smaller kind of sessions. Okay, and uh, The certification program will be live for 2 months itself. Okay, you can do the certifications with us. Okay, and the participation certificate of the boot camp will be provided very soon. Okay, if you completed your design certificates like for the IoT, we have the Cisco and the OS concepts and the Linux concepts. Okay, are you people ready? Just let me know. And whoever in the live, thank you for joining.